Okay, so here is a physics review. Let me just. This is the stuff that you should probably know by now. I'm not going to explain this stuff. I'm just telling you the stuff that you need to know. And if there's stuff that you're like, I feel uncomfortable with that, I don't feel like I'm ready for that, then you know where to look. But these are the kind of things I expect you to be able to do and understand at this point. The first is pre stuff. So this is stuff from actually the previous physics course. So you need to know Newton's second law, F net is ma. That comes in useful. In the special case where the net force is equal to zero, that's in equilibrium. You need to know work, the change in energy, where work is F delta R cosine theta. So this is the force applied, the displacement, and the angle between the force and the displacement. You should know that. You should know kinetic energy. Gravitational potential energy, I probably should know that too. Vectors, I'm not going to put a whole vector review here, but you need to know vectors. So R hat, R magnitude, all those things, because you need to use those to find electric fields. Add vectors, subtract vectors, multiply by a scalar, find the magnitude, find the unit vector. You need to know that stuff. Okay, so the first thing is electric fields, E. You should know this. The electric field due to a point charge is K, Q, R hat over R magnitude squared, where K is a constant, Newton meters squared per Coulomb squared. You should know other things about electric field. You should know that the electric field is obeys superposition. So if I have 2 point charges and I want to find the electric field right here, it's electric field due to that one plus electric field due to that one. And as vectors, you have to add them as vectors. So there's a lot of stuff going on here. It looks simple, but you got to find that position vector. You got to find the unit vector. You got to find this electric field vector using this. There's a lot of stuff going on there that I'm glossing over. That's stuff you should be able to do. You should be able to find the electric potential due to a point charge, K, Q over R. You should understand the potential energy. Change in electric potential energy is Q times the change in electric potential. If an electric field's constant, delta V is negative E delta R cosine theta. Okay, so E is electric field, delta R is the displacement, and theta is the angle between them. That's important. If you have multiple point charges right here, just like that, the potential also obeys the superposition principle. So the electric potential here is electric potential due to that plus electric potential due to that. But it's a scalar, so you can add them up as scalars. So that makes things a little bit easier. Okay, circuits. There's a battery, resistor, EMF, R. So you should know current, I, and what it depends on. It depends on a whole bunch of stuff: the drift velocity, the cross-sectional area, the electron mobility, the electron carrier density, and the electron charge. All those things. You should know the loop rule. Delta V equals 0 for a loop. You should know Ohm's law. Delta V for a resistor is IR, where R is Resistance. You need to know the definition of resistance in terms of its material properties. Rho, L over A, sorry. That's the resistance. Rho is the resistivity. You should know the resistance as a function of temperature. R as a function of temperature, which I don't want to write down because I make a mistake, but you should know that. Write it down. You don't have to memorize it because you can use your notes. The loop rule, that's that. So that's the loop, and if any loop, that has to be true. The node rule, I in equals I out. You need to know capacitors. You need to know the RC circuit. You should be aware of that. Internal resistance for a battery. You should know the resistance as a function of temperature. I said that. Power and energy. So power is a change in energy with respect to time, and that's I times delta V for a circuit element. I think that's good. There's a lot of stuff with circuits, so make sure. Series versus parallel. You should know the difference in how to find those. Equivalent resistance. I think that's good for now. Okay, so that's where you should be for physics.